Alright, so part 3 of 4, what we want to do is we want to fit the graphs through these equations, through these points now. But every time we shift this, the points move. And all of the graphs move together. In such a way, we have to position P and Q within the equation in such a way that it does that. So for example, if I put this 2 here, it connects, okay? It connects between the two, but if I move this, you can see it's not taking the graph with it. So I want it to move and the graph is going to move with it. So let's say I move it 1 to the right. That means that this over here should increase or increase or move 1 to the right, which means it's -1, right? And the domain likewise will also move 1 to the right, right? -9. And this will also move 1 to the right, which is my upper bound of my domain, to -4. And it connects again. Alright, so let me just do that again. So I got this original graph here, okay, and I've got an unslided version just to show you the difference. So I'm going to go from here to a version. I just copied and pasted, Control-C, Control-V each one. And I'm now moving this slider horizontally to the right. I'm reducing this by 1 because it'll go right, but I'm also increasing this by 1, and I'm also increasing this by 1, and suddenly it moves with it. But I want to do it in such a way so that if I move it again, I don't have to create another graph, the graph will move with it. So how does that happen? How did 5 go to 4? Well, the original value for P is at the moment 1, which is 1 more than that. In which case, if this original was going to be, for example, 0, right, which is where it is, then this should be, because P is 0, if I put P here plus 5, it's 0 plus 5, which is 5, right? Keeping the graph the same, right? Because P is 0. So if I put 0 into my equation, the value 0 for P, it will go back to the original value, which is 5. So maybe let me keep the original values for this as well. I'm going to put this back to normal, 5, -10, and -5. So you can see I want to keep the values the same. That's 0, okay? Now I'm going to put 0, I'm going to put P in here, but it's going to maintain its value, okay? How do I do that? Okay, because if I put it at the end, I'm going to minus P here. Now remember we plus P there, but we're going to minus P here, because if I minus P here, I'm still minusing 0 by the way, and that hasn't changed. Now let's test this, right? If I move this 1 to the right, okay, then the P values are not actually changing in the right direction. It's going in the opposite direction. Can you see that? They're going away from each other, and this is going to go in the opposite direction. So have a look at that now with regards to signs. I'm going to go negative P, I'm going to go positive P here, and I'm going to go positive P, and that's going to mean that if I shift this to the right, you can see now it's working together. We're now moving together. Okay, and I've now created a model, created an equation, I've changed the domain, restricted it by P, and I've also changed this domain by simply minusing or plussing P. I used a bit of trial and error to get there, but you can see that if I move P to the right, and that's what they want, it's moving with it. Okay, so I can remove this equation now. Now I want to do this for all of them. So I go to the next equation. Okay, let's go to the next one. Copy that, let's go back again. And I'm gonna paste it here. Alright, so this one here looks like it's needs to shift. I'm gonna shift this, by the way, from the original point. I'm gonna go set -1, -2, -3. So it's 3 to the left and 2 up. 3 to the left plus 3 here comes to 5, and 2 up comes to -3, and then my domain, remember, will change here to -5, and it will stop at 0 because that's what I want. Okay, so now it's going through there, which is great. Now when I shift this, I've just changed this to adjusted this so that it goes through that point there. If I shift this right, it's not going with it again. I have to do the same thing. So what if I just did exactly the same thing? Here we go. Minus P plus P and 0 plus P. It still connects. If I move it right, it's doing a good job. Okay. Alright, we're targeting P. What happens with Q? Ooh, Q is not working, so I still have to get Q involved in this as well. Okay. Any more space here? Q is my vertical shifts. Alright, so my vertical shifts meaning that this over here needs to also go up by Q. So I'm going to try doing the opposite of minus, which is plus. I'm going to plus Q here. Okay. And I'm going to do this one equation at a time. And if I move Q up here, it works out well. You see it's stuck. If I didn't have that Q there, what happened? The graph separates from it when you move vertically. Because this is the vertical motion, that's the horizontal motion. Q is vertical, P is horizontal. So like I did, plus Q. Awesome, I do the same thing here, plus Q here. Now my life looks like it's going to be exactly the same in terms of getting that turn, getting that shift, vertical or horizontal, perfect. Okay, go back again, let's get the third equation. We go back